and welcome to Geeks for Geeks. Today we would be discussing the problem shortest uncommon subsequence. So before moving forward, let us first understand what is a subsequence. Suppose we have an array of 1, 2, 3. Then even if we take some elements from it and we represent the elements in the same order as they are appearing, like we are taking 1, then we ignore this 2, and then we take this 3. This would be a subsequence of this given array. If we take 1, 2, then this is also a valid subsequence, and even if we take only one element, then this is also a valid subsequence. Now let us move forward to this problem. In this problem, we are given two strings s and tree, and we need to find the length of the shortest subsequence in S which is not present in T. Basically, we need to consider all the subsequence of S, and we need to check if it is present in T, and the shortest one of them which is not present would be a considerable amount for the answer, and the length we need to report it. So if there is no subsequence is possible, we need to return -1. Okay, and then the same definition of subsequence is given, and a string of length n has two n different possible subsequence. What do we mean by this? So let us understand this. Suppose we have a, b, c, then the subsequence can be a or b or c if we take a, b, or we take a, c, and then if we take b, c. Okay, now considering the three elements, we have a, b, c itself. So how many we have? We have 1, 2, 3, 4, 5, 6, and 7. But there was mentioned that we had 2 to the power n. That is 2 to the power 3 is equals to 8, which means there is also a null one. Fair enough? This is how you need to proceed. Now, in this problem, we are told that the length is 3. So if we consider the subsequence A, and B, then AAB is not present. Even if you write all the subsequence of T, no one would match this subsequence as AAB itself. Now the question arises that how can we find all the possible subsequence? Then only we can consider that if it is equal to this or not, if it is present or not. So to find that, what we can do is we already know about the recursive approach. I assume that you already know about recursive approach. Let us know about the iterative approach, that is known as the power set approach. Okay. So what do you mean by a power set approach? This tells us that suppose we have a string of length 3, then we need to iterate from 0 till 2 to the power n minus 1. That is basically 0 till the value 7. Okay. Now how can we just use 0 to 7 and we can find all the subsequence of the given one? We can find that by using this. Suppose we write 0 in the binary representation. It is 0. It means that no bit is turned on. This is 0, 0, 1. Okay. And this is 0, 1, 0. 0, 1, 2. So if we write this, then this would be like this. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So this means that the positions where the bit is set, we need to consider those. Okay, so we would just fill up the empty ones with the zeros that is present. So we consider the first one. Here, no bit is turned on, so we won't take any of the element itself. Then we talk about the second one. Here only the last bit is turned on. That means we would just take the C. So we would just write C. Then we talk about the third one, which is just taking out the B. We would just take out this B. Then we talk about the fourth one, which is talking that B and C should be included. So we just take this. And then we talk about 5. Then this would be just A, because the first bit is only turned on and rest all bits are turned off. The turned off bits won't be included. Then we go to the sixth one. If we go to the sixth one, we have A and C here. So we have A and C. Then we talk about seventh, which has only A and B turned on. Okay, then we talk about the 8, which has A, B, C, everyone turned on. So if you just see it, this is how you can get. So what you can do is you can simply iterate from 0 till 2 to the power n minus 1, and you can iterate over the bits, and if it is turned on, then we would just consider it. So how to check if a bit is turned on or not? So let us see that also. Suppose we have 1, 1, 0, and we need to check if the last bit is turned on or not. So we would just take with 1. Okay, this would tell me the last bit is turned on or not. if we want to check if the last bit is turned on or not, the second bit is turned on or not, what we would do is we would simply go to 1 0. This 1 0, this transformation from 1 to 1 0 is nothing but 1 left shift by 1 itself, which is this one, which would take the second bit. Now if we want to check the third bit, it is nothing but 1 0 0, which is nothing but 1 left shift by 2 itself. This is how you can check it. You can see the implementation, and this is how you would produce all the subsequence, and each subsequence you would generate the subsequence for S as well as you would do it for T, and then on the process of generating each subsequence from S, you would check if it is present in T or not. You can basically insert all the subsequence in the given hash map or something. Okay, so now let us discuss the time complexity. So if we generate all the possible subsequence, then this is nothing but 2 to the power n subsequence, which would be very large. Okay, and if you store this in a hash map, the time complexity would be log n for insertion as well as retrieval, and the time complexity would be big O of 1 in average case if it is an unordered map. Fair enough. So this is not feasible. This won't fit in the time limit. So now we need to think of something better. So we can see that in whatsoever, we can't really decide which would contribute to the shortest subsequence and which won't contribute to the shortest subsequence. So basically, we can see that we need to see all possible answer and then consider the answer. If we ever come across this thing that we need to see all possible answer, that boils down to the conclusion that we need to use recursion. Now that we know that yes, this problem can be solved using recursion, we should start thinking in terms of base case, that is the smallest valid case. Then we should move forward to the recursive step, and we should think that how we can compute the present values by using the past values. Okay, and then we should think about what would be the return type and then what would be the parameters. Okay, now let us move forward. So talking about the base case, it is the smallest valid case that can be there. So let us first see what can be the algorithm to solve using recursion. To solve the problem using recursion, suppose we have A, B, C, and then we have just C here. If we have C here, then we can say that yes, B is not present here. So B is the smallest uncommon subsequence that is present in this one. I can say that. Okay. So now in the same way, I can also say that A is also smallest uncommon subsequence that is not present. So we can definitely say that if a particular alphabet, okay, a single alphabet, if not present, then it would contribute to the answer. That means that it would be the answer. That yes, A is the smallest one. So smallest value can be 1, and we found the smallest one. So yes, this can be a feasible answer. Now let us look at one more dimension towards it. So we can say that if the particular character is present, then there are two ways, that either we would include that character or either we would ignore that character in the smallest common subsequence. We can do both, and the minimum of doing both would be our answer. Can we say this or not? Yes, we can definitely say this. So this would be the whole algorithm towards it. So now, as we know, and we would then discuss about the different steps of algorithms or the different parts of algorithm, and this would become more clear. And the implementation, after the implementation, it would be crystal clear. So let's talk about the base case. This is the smallest valid case. The smallest valid case would happen. Suppose the first string, this is the string S, and this is the string T. If the value, there is no elements in S, that means that the answer does not exist. If the answer does not exist, that suppose the size of S is N and the size of T is M, and we would take this consideration in the form of coding also. In coding also, we would take the same notations. Okay. So if N is equals to 0, then the answer would be -1. This is the first scenario. In the next scenario, the smallest one, the smallest valid case would be when m is also equals to 0. When m is equals to 0, that means any of the character from S would be an answer for that. So I would if m is equals to 0, the answer would be 1, and in this scenario the answer would be -1. Okay, these are the two base cases that we would consider. Okay. Now the next case, which is the recursive step. So first character, suppose the first current character is curve. So what we would do is we would try to find the current character. If the current character is not present, then the answer would be 1. If not present, if not present. If it is not present, the current character would be 1. The answer would be 1. But if it is present, what we would do is we would try to find the position of it. And if we are able to find the position, we would include or we would exclude. And in both the condition, we would take the minimum of them. Okay. So let us talk about the return type. So basically, we need to return the length of it. The length means that it would be definitely an integer. Now talking about the parameters, we need the string s, we need the string t, and we need the size of both. So we need the size n and m, and this is sufficient enough. Okay, for all this we have discussed. So now let us start implementing the recursive solution to this. So what we would do is we would use a wrapper function because we need the n and m also. So we would return an integer, we would name it as rec because we are solving this in recursion, and we can name it anything. The first one would be the string size of s, that is n, and int m, which is the size of t, and string s and string t. Okay, we have string s and string t. So I would simply say that if n is equals to 0, we would return a very large value, that is int max. Why? Because see, if we just return -1, that would count in the minimum. Okay, so I would just tell you where this problem would occur. So int m is equals to 0, then we would return the answer as 1. But suppose the answer is n is equals to 0. So if we return -1, then -1 would be the answer, and -1 can't be the answer. So what we are trying to do is, instead of -1, we are trying to return a very large value that the answer is not possible. Okay, fair enough. We would move forward and we would initialize the answer with the largest value because we want the minimum value. Okay, and then we would say the current element is equals to s of n minus 1, the last element. Okay, then we would start searching that element. So int j, so that we know what is the position of it. So for int j, okay, so j is equals to m minus 1. We would start searching that in the string t, and then j is greater than equal to 0 and j minus minus. We would start iterating from the back, we would try to search it. And if the current character, that is t of j, is equals to c, that is the current character, then we would simply break from there. Okay, else so if we are not able to find that j is equals to -1, because if this loop is ending, then j value would be -1 because we didn't came to the break condition. If j is equals to -1, that means that the element is not present. If the element is not present, the answer would become 1. Okay, so if the element is present, what we would do is answer is equals to minimum of include or exclude, that is rec of n minus 1 and then m and then s and t itself. Okay, and then rec of n minus 1, j and then s and t, which would remain the same, but here we are including it, so we would just take this as 1 and we would take the minimum from both sides, and that would be the answer, and we would simply return from this point. In this, let us talk about this int max. So let us see, just suppose this value is equals to int max. This value returned by this value is int max. So int max plus 1, and this is int max. Suppose int max. Okay, and this is suppose also plus 1. So if we try to have int max plus 1 in the value of answer, then this won't fit into the integer. So there are two ways of doing that. Either take a very large value, or what you can do is, here we are just adding 1. So subtract 5 from each of the int max, and that would be enough to solve this issue of integer overflow. Okay. Then we move forward, and the other probable solution to fight this issue is that to operate on long int, that we do in comparative programming. We try to declare everything using long int so that we don't fall into integer overflow. Fair enough? So what we would do is, we would have int max minus 5. Here also we would have int max minus 5. So now we have written the code. So now let us handle the value of int max also. Like, see, we would store the answer, that int answer is equals to rec of this. And if this answer is greater than equal to int max minus 5, okay, then answer would be equal to minus 1. And then we would return the value of answer. Okay, let us try to submit this. And yes, we got a time limit exceeded. So why did we get a time limit exceeded? We got a time limit exceeded because the value of S and T is 500, okay, and we are iterating of this, and the time complexity we are having is exponential, that is 2 to the power n. Why? Because we are making a choosing that this either we would include or we would exclude, and we are also doing a big O of m operation over that. Okay, 2n into big O of m itself. Okay, so now let's try to optimize this. To optimize this, we would use the concept of memorization. So what is memorization? Memorization is a way of storing the solution of the subproblem. It is like this. Suppose I got betrayed. Okay, I got betrayed by a friend known as Ankit. Okay, so next time when I would encounter the same person, Ankit, I won't trust him again so that I don't get betrayed and I don't repeat the same mistake again. So basically, I need to remember that yes, Ankit betrayed me. So in the same way, I would write somewhere, and before, so what I can do is I will just tell you a way. So I would have a diary. I would write Ankit betrayed me. Ankit betrayed me. And the next time when I start trusting a person, I would first check if that person has already betrayed me or not. So in the same way, what we would do is we would store the answer of each solution, and then before computing the value, we would check if the value is already stored or not. If the value is already stored, we won't compute it. If the value is not stored, that means we need to compute it, and before returning, we would save the result. And the next problem is, how would we memorize? Now, to memorize the solution, we need to observe the dynamic variables. So this S does not change, this T does not change. But if you look at the value of N and M, it changes on the recursive call. So that means we have two variables. So we need a array, 2D array of N cross M. Okay, so what would be the dimension of it? We need to observe the range of the variables. Like n would range from 0 till n plus 1. Why? Because we need the value n. 0 is not needed because it would be handled by the base case. So from 1 to n, I need those values. So if I want the value n, then I need to declare an array of n plus 1. In the same way for m also, like we would go from 1 till m plus 1. Why? Because we need the value m. That is why if we declare an array of n plus 1 multiplied by m plus 1, our issue would be solved. Okay, and we would store the answer. We would initialize everything with minus 1, and if the value is minus 1, that means that the value is not calculated. If the value is not minus 1, the value is calculated. So what we would do is we would declare an array of int dp of 501, 501 and 501. Why? Because the maximum value we can have is 500. Okay, so you don't need to pass the DP array again and again, but you can do that also. So before computing the value, what we would do is, if DP of n cross m is not equal to minus 1, then we would return dp of n cross n. Okay. Else, before that, what we would do is dp of n cross n, because this value is not calculated, so we would simply save the answer. Now, what we would do is, before computing the value, we would simply initialize everything with -1, like memset of dp comma -1 comma size of dp itself, and we would initialize everything with -1 at this point. Let us compile and run. Okay, now let us submit this and see if we can get an AC or not. But we failed at the test case 29. So I found this as a mistake. So what can be the probable issue of this? So if we look at the time complexity of this solution, this is n cross m, which is 500 cross 500, and then we are iterating over the whole m also. The value of m can be again 500. So which is nothing but 125. 5 multiplied by 5, that is 25 multi 125. And then we have two zeros here, two zeros here, two zeros here. That is 10 to the power 6. And then we have 1.25 into 10 to the power 8. Okay, so we have a very tight constraint. So if we have a very tight constraint, so we need to do optimization over that. Okay, so basically what we can do is we can pass by reference, okay, instead of pass by value, because pass by reference is much faster than pass by value. Why this is? Because if we pass by value, it creates a copy of that, but if we pass by reference, it passes the address of that. So if we just have this optimization, pass by reference and again pass by reference, if we compile and run again, and now if we submit this, let us see, and yes, we got an AC. So that's it for today. Thank you and have a nice day.